We will see in this tutorial how to choose a pump and find its operating point according to a network. This tutorial assumes that you know how to create a network by calculating the regular pressure drops and the singular pressure drops of each of its elements. And you know how to save a section and its elements in the inventory. We open a network section. This example section is supplied with the MakeFlux software. In this inventory, we have several elements that form our network. Each of these elements is calculated based on the same flow rate. In this case, we have a flow rate of 3.38 cubic meters per hour. We now want to test this network with other speeds. We will use for this the graphical analysis of this network. The network of the inventory is loaded in the graphic analysis. We can close MakeFlux and use only the interface of the graphic analysis with its loaded network. We are going to launch a graphical analysis of the network to observe how the pressure drop evolves according to the flow. The tested flow range is from 0 to 100 cubic meters per hour. We start the analysis. This graphic analysis makes it possible to detail the evolution of the pressure drop according to the flow on each element. This makes it possible to detect if an element generates more significant pressure drops than the others. We have therefore seen how this evolves. But now we need to choose and select a pump. In this interface, we have a hardware editor, which allows us to enter a pump and its performance, and save it in our database. Here we have some pre-recorded pumps. By selecting this pump there, we directly observe its operating point, which is 39 cubic meters per hour, with a pressure of 26 meters of water column. We can launch the detailed graphical analysis to visualize the operating point at the intersection of the pump and network load curve. We see the head loss curve of our network, its evolution according to the flow. The curve of the pump and the crossing point gives us the operating point of this pump with this network. It can be estimated that this network will operate with this pump at 39 cubic meters per hour, with a pressure of 26.2 meters of water column, approximately 2.6 bars.